Um, yeah.
Where am I at? So, well, it definitely looks
C,
like
C is the only logical answer that I can see. It can't be A.
well, I don't think it's C because it's not x squared plus y squared plus z squared. It's x squared minus y squared minus z squared equals 1. Let me take a look again. It's got to be the hyperboloid of two sheets.
You think it's A? Really?
Well, it follows the form.
But if you graph it coordinately, it doesn't make sense.
Here, let me screen share real quick. Where are we at? So it's read off the problem. It's like x squared plus or minus 1 equals y squared plus z squared, something like that.
Uh, well, basically, it's x squared over 36 minus 1.
Right. Well, it just would, if you move the y's and the z over, they'd both be negative like this example right here, right? And then if you move the 1 over, it'd be positive. That's what it looks like to me, even though it's got those on it.
Yeah, but well, actually, can you pull that back for a second?
Yeah, I accidentally clicked on the wrong thing.
Well, the one thing that I'm wondering about is the over 36 and stuff like that. Yeah,
Yeah,
I guess maybe it doesn't matter.
I'm trying to think how that would make sense. Hmm. I don't know, that's just kind of what the form looks like to me. I don't know. What do you think? Because I thought at first a spherish type thing, because that's the radius. But
It definitely is not a sphere because
yeah, I know. Yeah, I know that. But I mean, as far as the radius and stuff.
okay, but technically, isn't C also in that form?
Oops. Where is the quiz at?
Or I guess A for you?
Oh, for me, that would be A. A is in that form is all I see. I don't see anything else. The only thing that doesn't have are those. But all that would change is how far X would go out.
So wait, you think it's A?
I do, but I don't know if that's right or not.
Okay, no, that's actually the one that I think it is.
Oh, okay.
It's just I have different letters.
Yeah, you said C, and so I was like, man, I just don't see it being a sphere.
Yeah, no, B is the sphere for me.
Gotcha. Okay, well, that's what I thought. So,
And then what would it be considered?
oh, there's more to it.
Yeah, what
This
type of
is the. Let me double check. I think it's the hyperboloid of two sheets.
yeah.
I'm pretty sure that's what it would be. Yep.
All right. Well, let's move on to the next one then.
All right. Oh, come on, click it. Here, I'll stop sharing now, I guess, for a little bit anyway. Don't need me clicking since we're looking at the same thing.
So we got
Okay, so find the equation.
one. 1. Okay, so I have y equals x squared plus 2x plus 3.
Yeah, you're way faster than me, so 1 sec.
All right, I'm ready to compare answers when you are.
Yeah, I
It's totally fine.
I haven't really read over this one today. I meant to, but I've just been behind, so I'm just trying to read. You want to show me kind of how you did it?
Yeah.
Because I
So the first thing you need to do is, you know, set x equal to t minus 1 and y equal to t squared plus 2.
oh gosh, I was trying to go the hard route. Well, that makes a lot more sense
And
because
then,
this is something I've already done before.
and
I
then you
was trying
label
to,
for t and
yeah, I tried to make it too complicated. So then you just solve for t and then plug x in. Got it.
yep.
Something easy. For some reason, I was trying to do what was on the homework assignment.
Well, that one is on the homework assignment.
Well, I mean on the I just went straight to the projectile motion one, and I was looking at all this other crap and thought, what in the heck?
Yeah, I'm not terribly pleased with the homework having to memorize some of those equations.
Yeah, that's pretty crazy.
Not looking forward to this test. I think at this rate I'm going to fail the class.
It's pretty hard for sure. Okay, so you said you got t squared minus 2t plus 3.
No, x squared plus 2x plus 3.
Oh gosh, why did I put t in there? 1 second. Okay, so it was x squared minus 2x plus 3. Is that what you said, or did you have a different answer? Because I
Plus
think I
2x.
swapped. Well, it should be t plus 1. So it's x squared plus 2x plus 3, right?
Yeah, because you have to add
Yeah,
1 to both sides, so t equals
right,
x
right.
plus 1.
Yeah, I messed up my signs there. Okay. Yeah, I was trying to make this hard because, like I said, I was looking at that and I thought, crap, what is the formula? So, yeah, that's funny. Okay, so Okay, so the velocity vector is the integral of RT, basically, correct?
Derivative.
I guess that's where I was heading to start with.
It's the derivative.
Oh, it's a derivative?
Yeah.
Oh, I guess that makes sense because that's the position.
I only have that part memorized because of physics.
Gotcha.
Because the velocity is the derivative of the position, and the acceleration is the derivative of velocity.
So for the velocity, you get 1, then 2t, and then for acceleration, you get 0 and 2. Oh, it says when t equals 3.
Yeah, so you need both.
So the acceleration is the same, but the velocity is 1/6. Is that correct?
Let's see. I have the velocity as -1 and 6.
Hmm. How'd you get -1?
Uh,
Because it's t minus 1. The derivative of that would be 1
you
minus 0.
are right.
I think. I'm just wondering because I
No,
question a lot.
you're correct.
Okay, yeah, I question a lot, so.
Yeah. Yep. 1 6.
All right. And yeah, for acceleration, I get 0, 2. Because it doesn't matter what t is, that's what
Yep.
it's going to be.
Yep. All right.
Perfect.
Moving on.
Yeah, see, this one, yeah, I'm not going to do well on, see. Initial speed. So V naught is going to be 450 meters per second. And theta is going to be 45 or pi over 2, pi over 4.
8.1 seconds. I just did this last night.
Yeah. Did you do the formula? Wait, no, you need. What are we finding? Gotta look at it again. Oh, so we're looking for t. Give me 1 sec. I'm trying to find which formula I need to use. Which one? There's 3 of them, right?
Oh, there's more than 3.
There's plenty of them, that's for sure. Did you use the t equals Vy naught over g?
The first one is 2 velocity initial times sine of alpha over g.
2 velocities. Where's that one at? Oh, of alpha. Okay.
Velocity initial is the initial speed, so 600 meters per second. So 2 times 600 times sine of 60. Or sorry, I am reading the wrong problem. 2 times 450 times sine of 45 over g, which is 9.8.
Okay, let me plug it in, see what I get. Well, that's not the answer I got. That can't be right. Oh, I see what it did. 1 sec. I'm getting 32 something. What am I doing? Because I know that's probably going to be. Hmm. And T equals V naught sine alpha over G. Hmm. I don't know. I'm getting that.
We got 78.1 seconds.
78.1 seconds. Hmm. Yeah, I don't know. I got 64.9.
And how did you get that?
I just did the T equals, like you said, V naught, Vy naught over G, which is sine of alpha. Oh.
No, it's velocity initial times 2 times
Oh,
1 of alpha over gravity.
times 2 sine of alpha over gravity.
No, it's 2 velocity initial
Mm-hmm.
times sine of alpha over gravity.
Okay, let me try that again. Because I know you said that, but I still didn't get the answer. So 2 times 450 times the sine of 45.
Are you doing it in? Oh, wait a second. I did it in radians. Balls. All my answers are incorrect. Ah,
Oh, that time I got 78.1. But that's in radians.
fucker.
Which is what you said. Okay, let me try it again.
Yep. Back from
Well,
the.
it's weird. It depends on the math class. Some of them they want it in radians and not degrees.
Well, we're given degrees though. That's how we can tell.
Yeah, I know, but it's just crazy. Okay, 45 divided by 9.8. So 64.9, which I think is what I said I was getting.
Yep. 64.9.
Okay. I was questioning my sanity there.
Stupid radians.
Mm-hmm.
Next formula is velocity initial squared over gravity times sine 2 alpha
So that again, velocity initial squared
over gravity
oh,
times sine 2 alpha.
times sine 2 alpha.
Yep.
Hmm.
So 450 divided by 9.8 times sine 90. That is slightly different than my other answer.
That was V naught squared.
Yes.
Oh, so then I did that one wrong. So it's 450 squared divided by 9.8 times the sine of 90. Well, that's a huge answer.
It should be.
20,663.3, I guess, if you round.
We're rounding to the nearest meter, so just 20,663.
Oh, I didn't read that part. I read the one above it. Yeah, that's it. That's traveling a good distance.
Well, it's traveling at 450 meters per second.
Yeah, that's what I'm saying. That's pretty quick.
Yeah, pretty dang fast.
Mm-hmm. Okay, so 5 kilometer downrange. So does that mean that's 5 kilometers? What?
5 kilometers is 5,000 meters, so you need to set x equal to 5,000. So 5,000
Oh,
equals
I see.
5,000 equals velocity initial times sine, no, times cosine of alpha times t. And you're solving for t, and then you plug t into the y equation, which I do not have these memorized, so
Well, that's confusing.
I
There's
don't,
so many of them.
yeah, I don't have all these equations memorized. I have them saved on my computer, basically.
Mm-hmm.
So it's not going to help me for the test.
Boy, I hope they're not as crazy with it. All right, where I'm trying to look at that page that he's provided. Where are you seeing? Oh, it's the Vx naught equals. Oh, but it's the Vy naught is the magnitude one. Is that the one we're looking at?
Here, can you share your screen really fast? I'm not sure what you're looking at.
Yeah. Oh, you want me to share mine? Sorry. Give me 1 sec. Oh, come on. Is it screen share now? No. There we go. Okay. There's just a lot of formulas here, but I'm thinking what I have highlighted in blue. That's what we're looking for?
No.
No?
Well, kind of.
It's just a different, there's some different formulas, so.
Um, the first thing you got to do is figure out the x one to your left.
To my, this one? That's one.
No, it was on the same line.
Right here? That's a,
Up.
oh, this one.
Yep. Except for there's a t after the cosine a, cosine alpha.
So it doesn't say it, though.
Yeah, I know.
Nice. So we find the horizontal so we can find the vertical?
Yeah.
Because we need to find out what V naught is.
Well, we need to find the time that it is when it hits.
Oh, that's what it is, even though, because that's not on there.
Yeah, we have to find the time when it hits 5,000 meters. And then we take that time and we plug it into the y equation so that we know where it is vertically, which is what it's asking for.
Oh, I see. Man, that's just so crazy, huh?
I was doing this last night, which is the only reason why I know what's going on.
I'll do that. Okay, now let me read the problem again.
Alrighty.
How high overhead will the projectile be? So Vx naught. Do I need to convert that to meters, don't I? The kilometers.
It's 5,000 meters.
Oh, that's.
Five
I was
kilometers.
thinking it's 5,000 kilometers.
Oh no, that would
I don't know why.
go that far. We know that from the previous one.
Right, yeah. I was just thinking. Okay. 4, 5. Give me 1 second. I'll be ready. So it's 5,000 over 450 cosine of 45. That should give us t. So I get t is something like 15.7.
That sounds about right.
Okay.
I didn't write it down. I just attached it into my Google calculator. I wish I had my real calculator. Then I could go back and look at my answers.
Yeah, be nice.
Unfortunately, I don't have it on me. So,
Okay, so now we've found t, so now we need to plug that in and find where what vy is going to be. So 450 sine of 45 times 15.7.
and the y equation is actually uh, v naught times sine alpha t minus 1/2 gt squared
Okay, so it's not the one I was going to use. So v naught sine alpha t.
minus 1/2 gt squared.
No, because you have to.
Account for gravity and
Um,
how it affects acceleration and stuff
so I
like
had half of it right. Okay, so anyway, that part, the first half of it's almost 5,000. And then I said t was 15.7. So I get doesn't sound right.
what'd you get?
Well, maybe it is. 3,788 if you round up.
I got 3,790.
I must have rounded off when I did the time or something.
Yeah, I used the exact answer. I just plugged it in using
Hmm. I
calculator
thought
answer
I
functions.
thought mine came out exactly 15.7.
Mine definitely did not.
Okay, well then that's why I didn't realize I'd rounded. So 3790. So I was off by 2.
Yeah, but that means that you got the equation right and stuff like that, you know?
Mm-hmm. Boy, I'm gonna have to review all these like a billion times because they seem a little confusing.
No kidding.
Okay, so that was 3790. What is the greatest height reached? Isn't that the answer above?
No.
Yeah, I
The
figured
answer,
not. It can't be easy.
the answer above is when it hits how high it is when it hits 5,000 meters.
Oh,
That's just the
so it's
greatest
not the
height.
highest point. I see. It's where it hits 5,000 in the x direction.
This one, let's see if I remember the equation. This one is velocity initial sine alpha in parentheses squared over 2 times gravity.
And that equals Vy, huh?
That's the greatest height, yeah. Ugh,
Oh, I think I see the formula where it says Y max.
probably.
Mhm. Yeah, they just have 1/2 V squared Y naught over G. Okay. So let me plug all that in. So that's 450 sine of 45. All that squared over 2 times 9.8. I get 5,166 if you round it. I can't remember if that's what it wants.
5,166.
Yep, that's what I get.
Cosine to the third. That's disgusting. Ugh, I don't know any of my trig identities.
Yep, I don't either.
That's going to be disgusting. Why would he ask us to do that?
Yeah, I don't know.
Because you end up with the derivative, and then in order to find the length of a vector, you have to square them under a square root. That's going to be like sine to the sixth, cosine to the sixth. It's not, wait. It's sine to the sixth plus cosine to the sixth equals 3. Since sine to the second plus cosine to the second equal 1. Does it work like that?
I don't remember. I know how squared works. I can't remember. I remember doing it two different ways. I remember one where you could just, if you took the derivative, you bring down the 3. I'm gonna have to break out the rules on that. I'm looking at a thing that's showing the work, and it seems really complicated to actually prove it.
1 minus 3 sine squared x cosine squared x.
I don't know. I can find a good example. I feel like if I can get a good example, then I can kind of understand what they're asking. Okay, maybe this one will be the one I want. Okay, so let me screen share, and this is just the formula for sine. That So it would be n
You're
to
not
the
sure.
n minus 1, and then it's x cosine x. I'm not sure why that one x is there. But is that kind of the answer you were getting, that you were saying?
I don't even know. I was just trying to find if there's an identity or something.
Well, this shows how to take the derivative, I think.
Yeah, but we're not looking for the derivative. Oh, yes, we are.
You have to find the v of t first, I think, right?
I have no idea. It's way too complicated.
Yeah, I don't know either. So the same thing for cosine would probably be the case, where it would be opposite, plus you'd have your sine minus. And I'm going to look real quick.
My small person is upset.
Yeah. Okay. Happens a lot, I'm sure.
It's kind of life.
Well, what happened there? Oh, they're integrating that. That doesn't make sense. Yeah, it looks like. Wait, why is that n minus 2? Oh, it's just the way they wrote it. It's dumb. Anyway, it looks like it's basically the same thing, except for with cosine you have a negative sign, at least according to how they have it. So let me go back to this. So I'm thinking for the x coordinate, it's going to be 10 times 3 cosine squared t. Oh, maybe that's. Here, let me look at that one more time. Oh, I see. Okay, this is theta right there, the x. I thought it was another x just popping out of nowhere. That makes a little more sense. If I understand what it's even asking anyway. Okay, and then so that's sine of t. That's going to be negative 10, 3 cosine. Oops. Yeah, come on. Sine squared t cosine t. All right.
So what do you have v equaling?
Okay, so I just have the x and y coordinates, but for the x I have negative 30 cosine squared t sine t. And then for y I have 30 sine squared t cosine t.
Okay.
That's according to that those couple websites I went to, and that's kind of what they said the derivative of that was.
Okay, so that's what v equals.
Yeah. So now let me.
So now we need to find the length of v,
So
which is the square root of
boy, that's going to be a nightmare, isn't it?
that
Like you said, maybe it won't be as bad, but
squared plus the second part squared.
yeah. So it's everything squared. So it's going to be 900 cosine to the fourth t sine squared t
Oh my gosh.
plus 900 sine to the fourth t.
Cosine squared t.
Yeah, yeah. Okay, so we can pull out 900, and then that would just be 30 right out of the.
Yeah, divide by 900, so it's 30 times the inside. You could also pull out sine squared plus cosine squared, which equals 1.
Well, how are you going to do that?
Oh, you're right. Never mind. Well,
Well,
no,
there,
you're good.
well, there's some way I'm sure you could do it. Sine squared is or 1 minus cosine squared. Oh boy, that just seems ridiculous.
I don't even know.
Sheesh. Yeah.
Okay, so V equals 30 sine.
Wait, if you pull a sine squared out, or two, yeah, here, let me walk it through before I say anything, because now it doesn't make sense. Mhm. Okay, so I took out cosine squared of t from that equation, so that's going to be multiplied by cosine squared t sine squared t plus sine to the fourth t. Well, I can pull this cosine squared t out now, and so now that'll be 30 cosine t times the square root of cosine squared t sine t plus sine. What I'm going to do is pull out a sine squared. And so that should leave cosine, which we 30 cosine t sine t.
Wait a second. Wait a second. I got something.
Okay. I
If
don't
you
know if I'm right though.
if you pull out cosine squared times sine squared, then you end up.
No, I did not.
No, I was. 1 second. I did my own math, and I'm running this by you. You
No,
pulled
you're
out
fine.
cosine squared and sine squared. That leaves you with sine squared plus cosine squared on the inside.
Yeah, if you pull out, so you pull out the 9, that's 30, and then you take either your pick cosine squared t or sine squared t out from that equation. Which one did you do first?
Doesn't matter either way. If you take out cosine squared,
Yeah, it turns out to be the same.
then sine squared
So you can base
plus cosine squared
third.
equals 1. So that cancels that
Sounds
equation.
like you did at the same time.
You end up with 30
Yeah,
cosine
right. So
squared.
under the square one, the end result I have is 30 cosine t sine t.
Okay, so my very end result for the length of V is the square root of 30 times cosine squared t times sine squared t.
Wait, it's the square root of what?
Square root of 30 times cosine squared. Actually, you're right.
Peter's hard time. Let me check something.
Actually, it
Hmm.
wouldn't even need to be a square root. It'd just be 30 times sine cosine.
Yeah, my things processing a lot of information or something, so it's really slow picking up words you're saying.
Sorry.
And
So
it's not you.
I got 30 sine t cosine t.
Yeah, that's what I ended up with. So that's why I was confused when I heard a square root. But yeah, that's exact answer I think I have.
Okay. Well,
Oh, I need to write that in though. Cosine.
so now
Oops. Yeah, hold on. I forgot to do one part because I was doing the other thing.
now we just need to take v divided by length of v.
Yep.
So
So that actually simplifies quite a ways. It should be a negative cosine t for the x and then sine t for the y. Is that what you see?
no, because it's gonna end up being
Oh,
sine
it's this,
over cos. Oh no, you're right.
and then we have to plug in 0 to pi over 6 and then figure that out from there.
So it's negative sine t plus cosine t. Correct?
I have it backwards, I think. I have negative cosine t sine t. Because the derivative of the cosine is brings out a negative sign, which is the x coordinate. That's why I have negative cosine t anyway.
Okay, so wait, what was your first part?
So my first part, the derivative I have is negative 30 cosine squared t sine t.
Oh, okay. I get it.
Yeah. Well,
So,
that's what I did. I don't know if it's right. I just not sure. So.
so it's negative cosine t sine t.
Mm-hmm.
Okay. Understand your thought process. So, all right. Length of a curve. It's the integral of 30 cosine t sine t. The 0 doesn't matter, so we just need to plug in pi over
I
6.
guess. And let me go back to that. Okay, we found the tangent. Oh, so I see what I was doing. I was gonna plug that into the tangent vector. And I was like, well, that doesn't make any sense. Okay, so let me go back and make sure I'm doing the right thing. So we're trying to find the length of it. So we're taking the integral of it. Well, oh, of the.
Oh, we already have the integral.
Well, it's here. Let me show
So
what I'm looking at.
we have 30 cosine pi 6 sine pi 6. Which actually I think makes a real number. So
Oh yeah, you're right. But it wants the integral of that.
uh,
That seems like a funky deal there. Okay, so it's the integral from 0 to pi over 6. And that's the integral of 30 cosine t sine t dt.
alrighty, sine of pi 6 is 1/2. So we end up with 30 times 0.5 times
Isn't
1
it isn't
square
it
root.
square root of 3 over 2?
Yeah.
Okay.
So
So it's going to equal 15 times the square root of 3 over 2. Let
15
me
square
look.
root of 3 over 2. That's right. What the? It's not what they put.
Let's see. Well, according to here, let me show you this. Uh, see if I can find it real quick. Nope, wrong one. This one right here. So this is what I'm looking at. So it says we have to take, well, that doesn't show very well. So that says we need to take the integral of that 30 cosine t sine t.
It's the no, it's the integral of the original equation,
Oh, is it?
which we already have,
Oh,
which is the 30. Oh, wait a second.
well, just because it's the integral of the length.
It's the integral of the square root. So it's
No,
basically the length. Yeah. No, it's not.
so it's the square root or it's the integral of 30 cosine t sine t dt. Is that right?
Yeah. Which is what we got 15 square root 3 over 2.
Well, I mean, do we have to take the integral of the 30 cosine t sine t
I,
first?
I don't think so.
Hmm.
At least not from what I'm looking at. I don't know. I feel pretty good about the answer.
All right. You've never led me astray so far.
Well, don't say that. Then we're going to get them all wrong.
I was just trying to keep it positive. All right. So you feel pretty good about that one?
Yeah. I'll go
Okay.
ahead.
Let me submit mine, and then we'll see.
Okay.
Oh, it says I missed question 1 and question 4.
Oh, no, not question 1.
Well, it was probably my fault.
What's question?
Oh, it said instead of A on mine here. Am I still screen sharing? Oh, I am. Okay, good. So it's saying it's the spherical part.
Weird.
Well, I guess that makes more sense because it's not just straight lines for radius coming out
Yeah.
because they're rounded. So
And what is it down below?
it's a hyperboloid.
Okay, so that's correct.
Yeah, we got that right. It's just that's what I thought. Oh, it's got to be this one because it's a hyperboloid, but you can have a rounded hyperboloid, and I didn't think of that.
It's just so weird because it's missing a huge chunk of. Oh,
Yeah, but that's due to the radius, I think.
okay. Well, what did we do wrong in question 4?
Yeah.
I see.
What? Why did it do that? That's not even right. It did all of it wrong. Or is that saying that's what it is?
It's saying that's what it is, which is what I have, except for the 15.
Well, then why did I do that?
Wait, no. Click on it real fast. Oh, why did you put that down?
I don't know why I put that down.
Wait, you didn't put that down, did you?
I have not. Apparently, I did. Where's the?
No, go back to it.
Oh, no, I was just looking.
I want to see the 15 real fast.
Yeah, that's what I did. Okay. I don't know why I did that. I did that last week too.
Yeah, but last week,
It was the same thing. I wasn't thinking and did it.
he gave us credit for that one problem. I don't understand how that ends up being 15 though.
I think it's because we have to take the integral of that.
That
But
just,
it shouldn't matter because it will end up being. Well,
that,
let me do the table thing real quick.
that answer only makes sense if.
Yeah, I know. Okay.
I don't know. I think our answer is actually the right answer. I might send him an email asking him about that. I'm just
Yeah.
gonna turn mine in as is.
Yeah. Okay. Well, I don't know why I put the wrong thing there. That's funny. I only did part of the equation. I didn't do the when we finished it. But yeah, I don't know. It looks like when we do the integral anyway, it just cancels out everything and it is the same.
No, that's what I did. I had the right answer for the first part.
So 0. Yeah, I don't know. That looks right for this. Yeah, you're right on the first one. I don't know why I did it wrong. I think I wrote it on there without before I finished it, and then I did it and didn't turn back to it.
Still, we made pretty good time today.
Yeah, only because you did most of the legwork. I was only helpful in a couple spots, but with the physics problem, man, that was just too many formulas.
I know. I don't know how we're expected to do that for the.
Yeah, it's crazy.
I mean, once you know the formulas, it's easy to just plug and go, but so much to memorize.
Mm-hmm. How do you think you did with vectors? Pretty good.
I mean, I
I
think we
think
understand
I
them.
think that's easier than all this physics stuff.
I don't know. It's just with so much to memorize, I feel like things get pushed out.
Mm-hmm.
I don't know. I did so poorly on the first exam. I really want to like go over the exam because he gave us that little like these are the questions you got wrong. But I have no idea how I messed some of them up, you know?
Right.
Ugh, I don't know. Well, I guess I'll talk to you next week.
Okay, sounds good. So Thursday at 10.
Sounds good.
Okay. Thanks.
Actually, wait. Next week I gonna be busy. Um,
So the only other times I have group meetings would be Wednesday, and that's like 9 to 12, and then I'm gonna have a Thursday night 6:30. So I can meet whenever after that.
I can't do Thursday. What if we do Wednesday at noon then, or
Okay.
12:30?
Yeah, let's plan for Wednesday at noon.
Okay, I can do
Let me
that.
write it down so I don't forget, because I couldn't remember if we were at 10 or whatever, and then of course I ran behind. But so Wednesday at 10. Okay, perfect. All right, sweet. Thanks for your help.
Yep. See you next week.
Okay, see ya. Bye.